So good morning. The thing is to be that we are going to see about an encoder. Okay. So what is an encoder? Actually, the encoder is an electromechanical device that can measure displacement. So similarly, the encoders are normally a digital displacement transducer, which consisting of an mechanical element and a sensing herd, typically of what we have it of Abdina, optical type. Okay. So we will have a transducer which consists of mechanical element. So mechanical element that can be either of a disc or ruler and a sensing head which is to be an optical type. Okay, so the mechanical element, the thing is to be that we'll have a rotary type encoders. For a ruler we'll have of an linear type encoders with a deposited or curved patterns. So the sensing head, what will happen Sapna, it includes LED source and a light sensor in order to read the generated code. Okay, when you are saying about an encoders, actually they are used to translate rotary or linear motion into a digital signal. Usually this is for the purpose of monitoring or controlling motion parameters such as speed, rate, direction, or an instance. So when you are saying about an optical encoder, it is a complex system which converts a mechanical rotary motion into a usable electrical signal. Okay. When you are saying about a diagrammatic representations, so this is to be the diagrammatic representations. So we'll have of an input to be a mechanical rotary motion input, and the output signal we'll have over on it. Okay, and we'll have of an opaque area, transparent segment, LEDs assembly, sensing shaft, coded disk, light sensor assembly, photo transistors, everything. Okay, so apart from that, what we'll be having over on it, Abdina. So this is to be the mask over that. So in photo receiver, we'll have a schematic trigger output, we'll have a hot disk, we'll have a LED. So an encoder, when you are defining, it is to be a photoelectric emitter receiver pair looking through a slotted disk. Okay. So when you are saying about an construction, so what we can able to say that Abina, it consists of an rotor and a stator. So when you are saying about an rotor, actually it can be a metal, glass, or a plastic disc mounted on the encoder shaft. Similarly, when you are saying about an disk, we'll have of an optical pattern which is decoded to generate position information. Okay, when you are saying about an stator, it consists of a pair of LED and photo transistors. So where the LED which shines through the transparent section and received by photo transistors. So all these things will be amplified and it will be even converted. Okay. So the next thing we are in need to see about and what are all the types of encoders. So we'll have two different types, one to be the incremental and other one to be the absolute. So when you are saying about an incremental, actually it will measure the displacement relative to a reference point. Whereas in the case of an absolute, it measures an absolute position. So whenever we are, but when you are saying about the advantages and disadvantages, actually a missed reading will not affect the next reading when you are using of an absolute encoder. Actually, it only needs power when you are reading. But disadvantage, it will be more expensive or complex and will have a cost complexity which is proportional to one resolution or accuracy. Okay, let me see one by one. Incremental optical encoders. So when you are saying about an incremental encoder, its output contains a series of pulses when the shaft rotates. And similarly, each pulse corresponds to an increment of revolution of the shaft. Okay, and the disk has two channels which is divided into n equal angular intervals which is alternately opaque to unclear. So when you are saying about an n, which is called as an resolution or number of counts over on it. So where the pulse is counted by the processing electronics, which give the angular position of the rotor. For this purpose, we will need often two square waves A and B, or use with the third channel Z, which is synchronous with signals. So when you are saying about an A and B, which gives only one signal per revolution, it allows the user to initialize or reset the count. So this is the value of an optical encoder. So we'll have of an phase A and phase B and phase Z. So when a disk with an optical pattern revolves along with the shaft, the light passing through the slits is transmitted or blocked accordingly. So the light will convert it into an electrical current in the vector elements, which corresponds to each slit, and the output is as an two square.